All right, how's everybody doing tonight? I want to go over first what we did Kahoot, some final app resources and deadlines. This is your self-imposed deadlines, or I'm imposing them on you to get done to make sure you finish your app between now and the end of the semester. I suggest by now, if you've not yet decided to do anything otherwise, to use Replit to create your final app. Create, test, and deploy it on Replit. By March 12th, which is a week after next, we're off next week as a spring break. March 12th, I suggest having at least your app title and description on Replit in a see out or something for folks to see. March 26th, app basic functionality. March 9th or April 9th, app testing and debugging with your friends and family. And you can just send them a link to Replit so they can test it. I suggest on that 9th date to just let them see the app link and don't tell them anything and see if they can figure it out by reading your instructions and how to use the app on the main screen. And then April 23rd, completing your website on GitHub, which you started in week 3, I believe. Or you could use Weebly.com if you wanted to. It's a real easy way to create a web page as well, or a website. April 30th, upload your final code to GitHub, which I will walk you through on April 23rd, how to do that again, if you forgot. And then May 7th is your presentation where you'll present in front of everybody your app prototype in C++. So those are something you might want to mark down in your calendar, just so you'll kind of keep track of your app and make sure you get it done and get time to work on it and carve it out. Questions on that? Okay, I'm going to go ahead and switch over to Kahoot. You know the drill on that. This is actually bringing some data in from last week, and the last few questions are on top tech news of the day and the last week. Some top tech news I think you'll find pretty interesting. Snotch back and squirrel. All the big hitters are back, it looks like. Click on one more. All right, everybody in? Okay, let's go ahead and start. 10 questions. Blank members are global variables with static lifetime. Global or static? Static is the answer on that one. And static is what's going to be carried out throughout your application lifetime. All right. A class is introduced by either the class or blank keyword. Struct, structure. Struct is correct. Leaderboard. There are 3 visibility categories of class members: public, protected, and blank. Enumerated, private. Private is correct, 100% on that, good. Blank operator is used when a new value is about to be assigned to an existing object. Equal assignment. Assignment operator. Somebody's number 1. Easy number 2. Who said this? Classes make modifying small parts of code more streamlined. Somebody in this class. Jane, Brady, Joseph. There's a curveball there. Jane said that. Last week's discussion. All right, next. An old job application, this is tech news, is being auctioned for $50,000. Bill Gates, Elon Musk, or Steve Jobs? Steve Jobs, $50,000. And let me show you here real quick. Here is the job. Actually, resume. This is his resume, basically. Notice 1973, a year after he dropped out of Reed College. Gives his birth date. His name, Steve Jobs. He doesn't even uppercase his last name. It's lowercase j. Reed College, phone none, major English lit. But notice here where it says on access to transportation, possible but not probable. And then he gives skills as computer and calculator, special abilities, electronics, tech or design, engineer, digital from Bay Area, Hewlett Packard. So I thought that was interesting. Yeah.
I don't know if we talked about friend members of classes yet.
About what now?
Friend members of classes. Friends, you know the
Oh, yeah.
I don't know if we talked about it yet.
No. We're getting into that week after next.
When I was at NIU,
Uh-huh.
teacher goes, you'll remember this until you die. A friend has access to your private parts.
Oh, okay. I have to try to forget that one. No, just kidding. All right. Probably got a big drop on that one too, right? All right, let's go to the next one. All right, Apple confirms it now uses blank cloud for iCloud services. Amazon, Google, Azure. They now use Google officially. Well, they have been for a while. They just announced it. Next, #1 downloaded mobile app game on Android and iOS both. Monopoly, Minecraft, Grand Theft Auto. Minecraft is #1. 100% on that. Black Panther gadget, genius character name in the movie. Sherry, or Shannon. That's not a picture of her either. Sherry is the name. And then this last one's kind of an interesting stat. Again, about black women in technology. Only blank % of the computing workforce in 2016 made of black women. 3%, 10%, 5%. 3% in 2016. So we work on changing that. All right, so there's the leaderboard. Good job. I wanted to also mention, talked about the Apple, Steve Jobs, that one. There was a quote here on the article I highlighted. Talks about Sherry existing in a fictional universe, but she can inspire members of Black Girl Code and girls who wouldn't otherwise envision a career in STEM. It's a very powerful thing indeed. And so my wife and I saw the movie last week. It's pretty good movie, and definitely she does a good job of portraying a technology genius in the future. And so, yeah, well worth watching, I think, if you like Marvel comic movies. All right, tonight we're going to be getting into strings, and then also we're going to touch base on beginning with beginning with pointers. And so if you're going to week 7, solo learn this week is on inheritance and polymorphism. Reading this week is on in modern C++ and in chapter 12 of practical C++. Modern C++ it's operators, and 12 it's structs. All right, and let's see, we're going to go into examples first, and I've got a slide we're going to look at and then a couple pointer explanations and examples. Let me go ahead and open up my open up here. There it is. All right, so we're going to look at some pointer in C++, just beginning. You already went over it in your solo learn, but I thought we'd just do a little intro tonight. There's a challenge on your take-home, by the way. And if you've already done the assignment take-home, you can go back and do the challenge if you want. You don't have to, but I encourage you to. So basically, a pointer is a variable that holds memory of an address of another variable of the same type. So the key on pointers is the type that you declare a pointer as being. You'll see some examples here in class. The memory address is a location of another variable where it's been stored in memory. So in a pointer, you can pull the value or the actual memory address. You'll see in a second when we do the example, which will show you the memory address, the actual memory address in the computer of that value or the value itself. It supports dynamic memory allocation. And one of the most powerful things behind pointers, and you guys had some good discussion on classes like last week, pointers gives even more power to managing memory efficiently in a computer. Even though most of you have 8 or more gigs of memory on your hard drive, on your computers at home or your laptops, it doesn't mean we shouldn't be efficient with our memory usage on a program. And that's where pointers come in to help you be more efficient by reusing variables via pointers versus having to reinitialize them over and over and over and over again. Or instead of having 100 variables, using one pointer used hundreds of times. And that's where the difference is in creating individual variables versus pointer variables. So when you're declaring and initialize pointers, it's much like what you've done thus far, except you're going to be including in it the star symbol, the asterisk, before the variable name. So you got variable type, asterisk, variable name. Also the address of the operator is going to use the n symbol, and it's basically a unary operator that returns a memory address of its operand. And here is the way it looks on a normal variable. Int x equals 10. Now going to the pointer of that, int pointer equals x, and you'll notice the pointer, the asterisk, and then also the reference to the pointer with the operand symbol. Now the pointer will contain the address where the variable x is stored in memory, both the value of x and the memory address of x both. You'll see in a second. And so you'll see there on the little green box there, that weird text, the hexadecimal. That's the actual real memory address in the computer of that pointer that can be reused over and over and over again. You'll notice it's also an integer, which it has to be a certain type, but it can be reused over and over again throughout your functions and throughout your code in multiple classes. So there's a term called free store, which is a pool of unallocated heap memory in programming that's given to a program to use by the program for dynamic memory allocation during execution. It's basically about a 2 gig cap in 32-bit programs, and it's about a 4 gig cap on 64-bit programs. So even though we have more gap now in a 64-bit, doesn't mean we have to use it all, okay? And that just because we have 4 gigs of available memory in any app, again, doesn't mean we're just nilly-willy with creating variables. And that's where pointers help us be more conservative with our variable declarations. So the deference operator, again, that asterisk, is, again, what's returns the value stored the pointed address by the pointer. And here the operand is a pointer variable. So again, n x equals 10, declaring a pointer called PTR, referencing back to the variable x. And so when we see these out, PTR by itself will kick out the address of that pointer. and most likely you even have to put in the operand in there. And then the pointer address, the bottom one, will point out the value of that variable. And so now pointer can also be used to either change and display the value of X, but what's static about it is a memory location of that pointer, what's static throughout your program. And that's where it helps in memory. So 2 arithmetic operations and pointers, addition, subtraction, may be performed on pointers. When we add a 1 to a pointer, like an increment or a decrement, it's going to actually add to the size of the data type in points, and then the pointer is added to it. So an example here, we've seen like here, int X is the pointer. If we were to increment with a plus plus, the current address of X will be, say it's 1,000. If we do X plus plus, it will increase by 2 size of int data type. And so not just value, but it'll actually increase the int data type as well, making it 1,002, not 1,001, which you normally would have with a normal variable. So here's some rules on pointer arithmetic. The pointer plus plus increments pointer, dereferences unincremented address. This command first gives a value stored in the address contained in the pointer and then increments it in the address stored in the pointer. Plus plus pointer, increment pointer dereferences. Also, this command increments the address stored in the pointer and then displays the value stored in the increment address. Plus plus pointer dereferences a pointer and increments a value by the points, the points or the value of the points. This command first gives a value stored in the address contained in the PTR and then increments it by 1. And then lastly, one we just looked at, it's going to increase the value of the pointer and increase the value of the reference memory by 2. So pointer and arrays. Played with arrays up to this point. We can also use pointers and arrays as well. C++ treats the name of an array as a constant pointer, which contains a base address. And when I say address, it's a memory address, that hexadecimal number of the first location of the array. So an example here, the array of 10 in a variable array X. Here, X is a constant pointer, which contains a base address of the array X. So an example here on this one, if we have, so we can also store the base address of an array in a pointer. It can be used to access elements of an array, like a normal array. Because the array is a continuous block of the same memory location, because if you think about it, you can have 100, let's just say for argument's sake, 100 values in an array. If it's a pointer array, it has 1 memory address for those 100 values, versus a non-pointer array is going to have a single memory address for every single array from 0 to whatever, 0 to 99, 0 to 1,000. So you can see over time how that, again, is going to help in memory, but not only that, in app speed as well. It's going to make the app faster and more efficient. I kind of relate it to when you you're familiar with apps, you use apps a lot on your phone or whatever. Do you have to log into your app every time you launch it on your phones, both desktop or laptop or mobile device? Or does it remember it, especially on your phones? Does it remember it each time? Generally, right? It remembers that. Other functions, passwords in your browsers, it might remember it. Again, it's convenient to do that. Same with pointers. It's not only helping speed and memory allocation, but it's going to be more convenient for users because it's going to make them get their job done quicker for that app to get done. So in this example here, it gives an example of X. They're on the 0 to 4 there on the right. And then the pointer is referencing the memory address of X. X5, the pointer, PTR is an integer. Pointer will contain the base address of X, which would actually be the PTR, which would be the hexadecimal memory address, not the value. This one, so also write it like this, and this is generally how we'll see in our example when you're wanting to call an address of a pointer variable, you're going to put this in front of it, the and symbol. And when you do that, it's going to give you, again, the base address, not the value of that pointer where it's being called to. And by the way, modern day C++ leans more towards this, which is C++12 that we use. C++11 and before, you do not have to do that as often. Yes?
I was just wondering, so would that array be stored in dynamic memory, or would that be?
Dynamic memory. Yep, it would be. Yeah, it would try to eat up, it will eat up all the dynamic memory first before it goes other places. That's a good question.
So it would still be stored in dynamic memory even if you initialize the array first?
Yes, it will. Correct. But you're using a dynamic memory more efficiently than you would otherwise. So good question. So pointers and arrays, again, just remember, like an example here, is if you're trying to increment a pointer, you have to actually call the pointer itself to increment it, not just a dummy operator or a dummy variable. Has to be using that exact pointer because it's pointing towards the actual address. So it's not just a value anymore. It's a physical memory address that you're updating the element of. Here's an example of a handling. This is some of we're getting ready to go into the example code here in a second, but I want to end on this one here on the slide. It says using a character array, which we've used in here, and the words computers plugged into that character array. And the next line, char CP equals str with the pointer in front of the CP. If we were to kick out str, it would be the variable name, or actually it would be the address of it. Technically, in C++12, you'd have to put the N symbol before the str for it to show you the memory address. You'll see in a second. And then CP would use the actual value of that, which would be computer. So if we'll go back to week 7 in the first replet, which is the basic pointers. All right, this one here, I want to talk about some things that's important, especially when it comes to the version of C++ that we're using, which is 12 on this one here. And so basically, you'll notice something different here in the header file. We've got an IO stream, which basically you'll see a lot in C++. Name standard, we use that. Nameplate standard, string for strings that we use here in just a second. But then you'll notice here this pragma GCC diagnostic ignored, and then WW write strings. What that's for is to get rid of the annoying depreciated conversion from string. That's a constant warning that you'll get in modern day C++. So if you include that line of code in your header, when you're using strings, specifically strings with pointers and strings with characters, it's going to help ignore that. So if we go right into the first part on line 9, the comment, the deference operator, the asterisk, this one shows that, and also the pointer to the reference of that operator. So on line 10, we have int x equals 10, int pointer equals x. You'll notice the pointer asterisk before PTR. The reference is pointing to that address with the @ symbol, the N symbol. And then seen out, address stored at pointer will be displayed, whatever that PTR is, which should be at this point 10. Value pointed to the PTR will be displayed, again, PTR. This will be displayed by the pointer as well. Notice on this one, though, you've got the asterisk before it, which is a deference operator. So if we could run this just to see what the output is up to this point on lines 12, 13, 14, 15, let's go ahead and run it. Notice it says here the address stored at PTR will be displayed, and then it's got that hexadecimal number. That's actually line number 13. When you'll notice it's PTR by itself. It's the address stored at PTR. Next one, comment is value pointed to PTR is going to be 10 using the deference operator will allow us to get the actual value from that pointer memory address. Line 17, we're going to look at pointers and strings and what's called the unary operator, the N symbol. We have an array called str with the word computer. It's a char. And then plug into that str using an str array. We're plugging it into a pointer reference. And using the variable name on line 21, using variable name, put unary operator before the CP and run it. So we're not going to do that right now, but you'll notice both outputs for under using variable name, which is actually line 22, kicks out computer, and line 24 kicks out computer. All right, but let's do this. Let's put the unary operator before the CP and run it again to see what happens. And so we can just put this actually right here before the str and run it again. And it should change your value of that pointer to the memory reference of that pointer. Once you look at that number real quick, if you would, to the top reference and the bottom reference. The top reference, which was the first C out, the first part of that pointer is pretty much the same. It starts ending, you'll notice, on the last two spaces. The top one's 34, the bottom is 2B. And I'm just wanting to show you that they are different in the memory allocation. And let's run this again. Remember 34 and 2B on mine. Yours is probably going to be different. Mine's 32 and 2B. 34 and 2B. Now mine's 1, 4 and 0B. And the first part has changed as well. And yours will as well. So every time you run this, it grabs a memory allocation. Where is memory allocated that pointer specifically on that drive? Now in this case, it's the hard drive of the Replit server, wherever it's located out in the world, is where it's running this from. Okay. And so every time you run it, it's going to be a different reference pointer to that memory location. Make sense? It's not going to be the same because it's pulling it at runtime each time. Now let's go to the next section, the array of character pointers. And this one has an array called vehicle. It's a char array with a pointer reference. And notice in it, it has char or car, van, cycle, truck, bus. And it has a for loop. And it's looping that array and putting the unary operator before it and run again. We're not going to do it right now. You'll notice on this one, it shows the actual normal array, right? What? Car, van, cycle, truck, bus. Now, let's put the unary operator before vehicle on line 30, the N symbol, before vehicle, and run it again. We should now get a memory allocation of each one of those within the array. And you'll notice the family it's in is all the same. The family memory allocation is all the same, except for the last two. So 0, I have 0, 0 mine, 0, 8, 0, 10, 0, 8, 0, and then 20, right? Then I'll just run this again. Let's go and do it again. You'll see it again will change accordingly. And so we can keep running this over and over again. That memory allocation is going to change because, again, it's pointing to an actual real memory spot in that computer, or in this case, the server. Let's get rid of the N symbol. Run it again on line 30 and bring back the value. So the reason I wanted to show you the N symbol on that, or the operand value, the unary operator, is to show you that it's actually updating. When you use a pointer, it's using the same memory allocation every time and changing just the value. Memory allocation stays the same during runtime. Okay. The only time it's going to change is when you do what? When is memory allocation going to change? Yeah, when you run the program again, then it's going to change. While the program is running, though, during that duration, that memory allocation stays static. If you don't use pointers in your program, which we haven't up to this point, those memory allocations are not only going to be larger, but they're going to be more frequent and more widespread in your application. And so instead of an app using 10 megs of memory, we might use 100 megs of memory, all because not using pointers. Does that make sense? Because you can use pointers over and over and over again. Specifically, you'll see when you start using it in functions that's called throughout your application, where you're calling pointers and functions. So let's exit out of that. Next one, we're going to actually add some stuff to it, which is the pointer examples. So this one, let's go ahead and run it as it is, and then we'll go over it. So this one, when we run it, it says before swapping, the values of A was 1, the value of B was 2. After swapping, value of A is 2, value of B is 1. So in this example here, we're doing a function prototype that's a pointer prototype to swap values. That's all we're doing, okay? Let's look at the line 5 and 6, or line 6 actually, where we declare the prototype, pointer prototype. Notice in there it's got 2 integers. And remember, it goes back to the definition of a pointer. A pointer just has to be a type, and it can be referenced multiple times throughout your application. And so when you declare a prototype of a pointer, you're only declaring the type of that argument. So in this case, it's 2 arguments, which are 2 integers being referenced in that prototype. In the main, on line 13, we declare A and B as 1 and 2. C out before swapping, A is 1, B is 2. Makes sense, right? Because that's what you declared them as. But look on line 18. We call the swap function. And in the swap function, if you go down to line 41, you'll see that the swap function brings in 1 and 2, all right, as integers, and we call them N1 and N2. I pull in, declare a temp on line 42 and put N1 in the temp, and now N2 becomes N1, temp becomes M2. Now, could you just do N1 equals N2 equals N1, and then N1 equals N2? No, because then it would basically be the same. N1 would be N1 would become N2. Let's say if you put, N1 was 1, N2 was 2. If you didn't put a temp in there, both numbers would be the same going back. So that's why I used a temp in this example here. So let's go back to the cout. After the swap, it swaps those numbers using a temp. I use a temp to do that. Then after swapping, it's basically the same cout on line 15 and 16 as it is on 21, 22, but it's swapped it in that function for the pointer. Now what I want you to do is this. I've already done some of this for you, but in line under line 8, which is line 9, declare a function prototype called swap2 with 2 integer pointers, or 2 string pointers this time, I'm sorry, not 2 integer. And remember, pointers have to have the N symbol after the type. The type. So in this case, it's going to be string type. And I've already included in there the string header on line 3, so you don't need to worry about that. After you've declared that, on line 24, declare a first name and last name string. Line 26, I tell you to cout to get enter first name. Line 28, using the get line, get the first name. Line 30, comment, enter last name, cout. Line 32, you're going to use a get line to get the last name. Then on line 34, ask you to call swap2, entering in first name, last name. Then you're going to cout, my name is first name, comma, last name. All right? That's what you're doing on that one. All right? And what should happen is first name will become last name will become first name. So if I enter my name in, it should be Conkle, comma, Chuck. My name is Conkle, comma, Chuck. So spend a few moments doing that, and then I'll kind of show the answer on the overhead in just a second. I'll freeze the screen here. Take your time. Use the same logic that was used before, exact same logic. And in fact, in the prototype, I have it in there for you already. Below, the full fleshed out prototype is already done. So it's just a matter of putting the information that you need in the main and the function prototype at the top of your code for swap 2. This is not free. I'm having you turn this in just for fun. You know, play with it, and then we'll go over it. If you get something wrong, that's okay. We'll help you with that. I think you guys and I need a little Thunderstruck song for this one from AC/DC. I don't know, maybe.
At PetSmart, we understand that different
Or PetSmart
pets
Radio
need different
first.
food. That's why we're always adding new brands like Rachel Ray Nutrish. So our wide assortment, including Science Diet, Blue Buffalo, and Pro Plan, just got even bigger. Why shop anywhere else? PetSmart, for the love of pets.
There we go. That'll help you. Up in your main though, is where you need to flush that out. You need to declare a, yeah, you can get rid of that swap too, because you're not going to get that at all. Because there's a function prototype. This is a string. So you need to declare first name, last name as a string, and just follow those instructions on comment. Good. 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 Wow. All right. Know some of you still working on it, but let me go ahead and, it's good, sir. Give you my version. Get rid of the AC/DC highway to hell here. All right. Or not, maybe. Let's keep listening to it. All right. All right, so first thing is on a function prototype for the pointer, you should have point swap to string and comma, string and that. Inside the main, declaring your two strings, first name and last name, string, first name, comma, last name. Next, C and out to enter first name on line 27, 28, or 29. C in to get the first name. 31, C and out to get the last name. 33, using the get line C in to get the last name. 35, calling a swap to pointer function and throwing to it first name and last name to bring back the value for those two. Then C and out first name, comma, last name. And so I'll go ahead and run mine again. All right. And in the function, again, we use a swap because it's we're swapping two characters. So we have to use a temp for that. Otherwise, they both be the same value, either be N1 or N2. And then when it comes back, remember it's since it's the prototype's already been declared. And somebody had the question, which was a good question. Do we have to put in the N symbols if it is a pointer prototype? And you do. If you don't, it'll error out. I'll go get rid of mine to show you. It'll actually say in the area undefined reference, not knowing, what this prototype is for because it's not used throughout. Now, right when that prototype is initialized, we now have the two pointers for those two strings available in our prototype. And whenever it's called here to the prototype pointer, that's when those values to that original pointer are now changed. Now, if we were to go in here and play with this a little bit, what value could I put in here to kick back instead of my name Chuck Conkle? Let's say I wanted to kick back the memory location of Conkle. How could I do that? Is there only one way, or is there maybe different ways to do it? What's the best way you could think of? Go ahead. In front of last name here? Okay, let's try it. Now, why is it blow up, you think, on that? It's a good point. That's a good, I'm glad you answered it. Right? But is this a pointer last name right now? But when does it become, where is it a pointer at? Where is it pointing the reference to? Where should I do it at? We know it's not in the main, so it's going to be here. So if I want to do last name, remember we swapped, which one should I put the N symbol on? Should I put it on N2 or temp here? Because N1 is what? First name. And now it's going to be last name. And 2 is last name. Now it's going to be first name. So if I wanted to bring in the last name, should it be N2, you think? Or temp? How many think's N2? Okay, one person. That's all right. I'll go with that. Nope. Again, we're doing a reference back to that. What else? Nope. Yep.
Put it in your C out.
What is it?
Put it in your C out.
Put it in my C out. Okay. And you want me to put it in here as a C out or up here in the main? Up here? Okay. Then we do last name.
What address you on?
Do what now? You want me to do it right here?
No, in your C out. I just don't know which one it is, the first name or the last name. Because I'm confused now. Because you swapped them.
Okay. Well, you want me to try both?
No, in the C out. In the C out.
Right here?
Yes.
Which one do you want to try? First name, last name?
What address you want?
Okay. That's all right. Find out, right? Oh, there you go, Jack. You got it. All right. So it's actually in the C out. Remember, though, that's after the pointer has been applied. Been after, because here's where the call was done, right? On line 35. So once a call was done to that pointer function, first name and last name now become pointer references, all right, with a memory location. In fact, let's go ahead and play. I'm going to do both. I want you guys to do both of them. We'll do first name and last name just to see what the differences are in the two references. Shouldn't be much, but it'll be a little different. The first part is going to be the same. So let's see, on mine, it's the same up through the last 2, and then it changes. My last name is 80, then 60. But why is 80, why is last name higher than my first name, you think, as far as numerically? Yeah, first name was entered in first, which is 60, all right, which even though the swap happened, it still stays the same. That's 60. That's my first name. Last name is 80. If I run it again, it's going to stay the same. We'll do it one more time. That logic should still carry out because it was called first, it's going to stay first. Now, this one right here, it calls it as AO and then 80. Okay, so 80 is going to be before A. It doesn't change into letters until after the numerics are exhausted, meaning after 9 is then going to become A, then B, then C, so on and so forth. Right, so that was first, that was second. Let's run one more time. This time we have 20, then 40, which makes sense. First name allocation, second name allocation. Make sense? So again, you're playing with and manipulating. This does not become, first name and last name does not become usable as far as a pointer until after it's been called as a pointer. All right, which now it has after the swap to. If we remember, if we put it up here before that call occurs, should blow up the code. In fact, it'll tell us in the code what's going on. It'll say here, invalid initialization of non-constant reference from the R value string, and it puts in there the little asterisk, also known as, and then it gives the char type, and it goes on and tells on line CBP note and passing argument one avoid swap. It gives a key to why it's not. It's because it's not been called yet. So again, on line 35, first name and last name is still a normal string. Okay. After 35, there's still a string, but they're now a pointer string. Make sense? And we can change this forever. You know, we can call swap to multiple different times because they can be called multiple different times. And so even though we've CN'd these already, we want to just play with it and show you. I'll come in here and put another, we'll just hard code these in right now. I'll just do John, we'll go old school. John Wayne, anybody remember John Wayne? We'll do John Wayne. Okay. And forgot the S. And then we'll do another C out after that. Call is that calling the, oh, it's because it's a constant. It declares it as a constant. I'm sorry. Cannot be called again in this way anyway, because it's declared, first name and last name is being declared as a constant in here. That's why. That's right. So protected shows you the protection of that as well. There we go. Cool. All right, questions on that? Okay, let's do this real quick. Yeah.
I was wondering, why didn't it work in spot 2 when we tried to put the memory address before like N1? Why doesn't that work?
Because it's not been utilized as it's not been converted to, converted is the right word. It's not been converted to a pointer yet.
Even within the swap.
Right. Even within the swap too, it's not been converted. But until it hits this here, it's not been converted on the compiler.
Right there. I mean, like if you were to put the and symbol right before.
Oh yeah, good question. It's actually protected within the function. So these two, this is not even a pointer. None of these are pointers. The only things are pointers is a prototype, which are these values here. So when you call them here as a swap AB, or I guess a bad B, whatever it was, first name, last name, after that call, then first name and last name within those parentheses become pointers and reference to those pointers. So, right?
In the function body,
They're private. Yeah, private variables is all they are. Yep, good question. All right. So again, that's just a refresher, kind of an intro thing to pointers. Hopefully that helps a little bit. On the assignment this week, I want to go, I know a couple of you already finished, but I want to kind of give you a challenge on this one with pointers. So I'll go ahead and click on that assignment. I'll go to it real quick to show you the challenge for this week. And if you had to turn in last week, please turn it in. You can still get credit for that. Okay, so we're going to 7, int char. And so this one here is, again, characters and strings, which is important to understand more about it and follow the steps in characters and strings. It basically takes you step by step. On the first segment goes over entering in a char, kicking it out as a char, and then next segment goes over integers and how to do that. Next step goes over changing integers to floats. Then last, strings. Understanding how to do CNs on those is important because like char CN, you can just do a CN. A string CN, you have to do a CN.get line. And understanding that a little bit better is probably good. But the challenge is once you've done the exercises, which basically you have pretty much all the code there to give you to do the exercise, just go one by one and go through it. The challenge is to create a pointer function prototype called void printout with 4 pointer strings. So you'll have, and I'll give you an example here, string, end symbol, string, end symbol, string, end symbol, string, end symbol. And then create a pointer function named the same with 4 pointer strings, string OP, F, L, and E. Concatenate the string to output something like hello, check concal, period, your email is, whatever. The OP is going to be used to concatenate the string. That's the only reason for that variable is to concatenate it and bring it back to the main. So in the main, you're going to add string variables for email and outputs, which is not in the scope above this assignment. In the main, you're also going to send variables like we did in the example exercise to the pointer function printout. And so this is actually the call that you will make. I gave you that code there. One of the things I'll mention too is I skipped over it. Initialize your outputs variable empty quotes to initialize it. That'll cause a compiler error if you don't initialize it before you print it, before you call it to the pointer prototype. Then here on the call using the printout function, that's all pointers. Outputs is going to be nothing initially. First name, last name, email, you'll have content from for your first name, last name, and email. In the pointer function, you're basically going to, in the printout function, you're going to output it to and concatenate the string like below. And I put in here a little note on concatenating strings if it's been a while for you. When you're concatenating a string, it's unlike a cout string. If you just want to concatenate a string into a variable, in this case, it's a string variable. Remember, in order to concatenate a string, you need to combine the strings of text with variables using the plus operator. So I'll give you an example here. Let's say your variable string is called variable output equals begin quote hello end quote space plus the variable name plus and then end your string semicolon. That's going to concatenate your strings with your variables all together. So the sample output for this is going to be you enter your first name Tom, last name Cruz, email tcruz@topgun.com. In the movies tonight, referencing the Top Gun movies, which I know no one has seen here, right? Any Top Gun people? One person. Okay, 2 people. Then it'll kick out, hello, Tom Cruise. Your email is, and then that's what it will kick out. Ooh, right, Val Kilmer. I don't think so.
The classic.
He was a rival.
Oh, that's right. He was on the other. He was a rival. He was a bad guy. Yeah, yeah. We're not bad guy, but yeah. Same team, but rival for sure. Okay, so challenge questions on that. I give you as much information as I thought I could without giving you everything on that, but it's enough to get you started, I think. And again, using a function prototype, pointer function prototype for this assignment, adding to the take home already, which shouldn't take you long anyway to do the take home. The reason I threw the take home in like I did was over the last couple of weeks, some confusion, which definitely can happen on CNs. Where do you use a CN? Where to use a CN get line? Okay. If it's only a single character or a number, CN works perfect. If it's anything beyond that, you need to use a cn.get line. All right. And that's going to do what?
Weird stuff when you press the button.
Yeah, exactly. It's very weird stuff if you don't do it that way, which I know you've already had happen. And so this will help you just kind of refresh your memory on that because you're using these all the time in your programs, okay? All the time. And so it's easy to forget them. So anyway, challenge question. All right. So I think everybody can complete the challenge question. Look at the two, especially the last example we looked at in class to help you with the challenge question. Another challenge to help you complete that. All right. And I want to make note too after I go over the review questions as always. And I still have yet to post last week's and week before last solution. I will do that. And then the discussion. And yes, you might be part of the Kahoot next week and the discussion possibly. So make sure and read each other's discussion maybe. All right, so here we go. I wanted to talk about a couple jobs that have yet to be posted, but I just got them in. And let me open up my email so I can make sure and get it correct. So you guys will be the first ones to see these job postings. Both of them are really good job postings, I think. It's with Winnebago County IT department, downtown Rockford. Gus Skinter, which I worked for Gus for a little bit, a number of years ago. And great place to work, beginning IT job, I think. So let me see, it's from Conley. You sent it to Conley, so let me see if I can find it here. Search. There we go. Wow, check this out. It's awesome. That's what Jim said. It is pretty good. So Gus sent to Jim, and I've yet to post it on our website, but I thought I'd tell you guys about it because you might want to take it, right? So if you are interested in any of these three, let me know before you leave tonight, and I will wait a couple days to post these jobs if you're interested. All right. First is help desk analyst, and by the way, all these jobs they will train you on what to do. You don't have to have any experience whatsoever. You just need to be an RVC student. And then I can say, yes, Gus, you should hire this person and you will get hired. That's how easy it is. Yes. What? It is paid. Yes. Good question, Jane. I believe, if I'm not mistaken, most of his internships are anywhere between 12 and 18 bucks an hour.
40,000.
You want to? Yeah, it is. Yeah. There you go. So it's on the board. Yeah. So I was actually lowballing it. $40, 40K is $20 an hour. So yeah, it's 20 bucks plus, 20 bucks plus an hour. So help desk analyst, thank you, Jack, 40K. PC server break fix, 45K. You get to take breaks in a PC server room on that one. No, just kidding. Break fix means you get to fix stuff, kind of troubleshoot. That's Gus's way to put it. Anyway, level 2 and 3 technology engineer. This is like a general help desk, like hands-on help desk, not on the phone, but like you're going out fixing stuff from the help desk when they tell you, Joe's printer won't work, go over to this building and get it fixed, figure out what's going on type thing. So all three of these are for college, I think, great. And they work around your school schedule as well, by the way. Gus will work around your school schedule. You won't be meeting Gus. You'll meet Gus initially. Then after that, you'll be working with Brian, that's over IT, which is a really nice guy. So anyway, if you're interested in any one of these three, do not email me. Just come to me right before you leave and tell me you are definitely seriously interested in one of these three jobs. Tell me which one it is you're interested in, and I will not post it until you tell me otherwise. Sound good? Questions about those three jobs? All right, come up and see me then. Those of you that are interested, I know Jane's already interested in one, so hurry up, Jane. And we are done for the night. Come up and see me, definitely, if you're interested in one of these three job postings. Let me kill the